Wonderful. So good morning, everyone. My name is Akashdeep, and today I'll be talking a little bit about my research. And so I do a lot of machine learning and financial forecasting as part of my research. So let's talk about that. So I'm a PhD student in quantitative finance. Actually, got my master's and my bachelor's here at Texas Tech. I actually started here as a petroleum engineering student, and when I did so if you want to get into petroleum engineering here, you have to do the foundational engineering for 2 years, and then you have to get 3.4 something to get into the petroleum, and then you go in there, and then you continue. So I got the GPA and everything, but it was like a lot of abstract concepts that like I didn't know what these equations mean. So I switched to physics, and then I did a bunch of computational physics. So I learned Python, and of course, the next step was machine learning. So during my master's, I did some math courses, some physics courses, and then now here I'm doing machine learning, so in finance. So today I'll go through some of my points on my recent publication on the Monte Carlo simulations and using ensemble machine learning models for financial forecasting, and how I plan to do similar thing on high frequency data. So let me just give you a basic overview of like what machine learning is. I'm pretty sure most of you understand it or will read about it because it's like the news these days. So for stocks, the data mostly looks like open, high, low, close, and then volume. So we call that OHLCV data. And then we have time period. So we start with, for example, Monday, last Monday, Tuesday, Wednesday, and so on and so forth. In high frequency data, the trading hours, they are from the market opens at 9, for example, and then close at 3:30 or something like that. You can get minute-wise data. Like many of the trading firms these days, they even go to seconds and then milliseconds even. So every trade that is executed per second, they have like a huge list of all the order flows. So you have like all these data, and then oftentimes that you see the plots of the stock prices, it is the close data plotted against the time. So one of the problems in finance is that is the stock price, for example, if we are right here, for the next time period, is it a random walk or not? So is the price determined by a toss of a coin, for example? So if the answer is yes, then pretty much there's no way you can make a profit by trading consistently because it is a coin toss. So it should be 50-50. But a lot of trading firms and pretty much all of the financial research that people do is finding that edge. So you can make that 50-50 to 51-49 or something like that, or even better. Like I know there's like a firm called Renasa Technology by Jim Simmons, I think. He's a mathematician, also popular in physics. He invented the Chern-Simons equations. So they make like I think he passed away like during the COVID, I think, or after COVID. They did 60% every year for like 20 or 30 years. So that is like 60% gross profit. So that is insane. So they must have been using like, so they must found an edge. That's the point. So all we are trying to do is like predict at the next time point it goes up or down. So if these patterns repeat themselves in the future, so for example, at this point, have we ever in the past gotten to a point where the volume spikes at this point are similar to the last time the same pattern occurred or not? So machine learning can help with that because it is an excellent pattern recognition tool. So for this research, what I did, we'll exactly discuss all that. So in traditional forecasting, so as I told you, the modern data sets, they are not just daily data. They're like minute-wise, second-wise, or even millisecond-wise. So you can imagine like if a big investor comes in and they want to buy like 100,000 shares of some company. If they put in their order, the next second the volume spikes up and everything is messed up for a second. Then it takes a bit to adjust, and then the graph flows normally. So if there is a big order, so example, if this is volume and this is the this price. So if there's a very high volume and the price reflects something like that, and then sorry, this should be time and this should be volume. So if there's a very high spike from the previous data point, this will mess up the models. So the current research that I'm doing we have to deal with that a lot because if, for example, all day the volume just stayed around at some point, and then, for example, Warren Buffett wants to buy some apple or sell some apple, the volume spikes, and then after a little bit, it comes down back again. So this is kind of an outlier. We want to filter that out, but it tells us a lot about the price. So we are actually interested more in this than the other data points. So one of the techniques that we recently used was we can take the median. Let's say median stays here. Sorry, I can't say this. Median stays here, and you take like a standard deviation above that, and then filter every data out, and then plot it against the current price and like make a correlation analysis or something like that. So that is the challenge. So for risk assessment, mostly how risk assessment is done is using, for example, this is a Monte Carlo simulation. It's quite interesting because the term Monte Carlo simulation was actually invented during the Manhattan Project in 1940, and it was, I think it was coined by von Neumann and Stanislaw Ulam. He was a Polish mathematician. So what Monte Carlo simulation does is it is like you bombard the sample space with a lot of predictions, and where the predictions overlap, you can get a pattern. So here's a example. So if this is a roof, and we have a bucket with some area. So what is in essence of Monte Carlo simulation is like, for example, if it starts raining, you bombard the entire sample space, and you know how much it rained, and you know the area of your roof. You can calculate this area based on the volume of the water left. So, for example, what in terms of financial forecasting Monte Carlo does is it generates a lot of possible scenarios, hundreds of thousands, and you give each of them a certain starting condition, like basically a starting condition, and then soon after, you'll see that you'll get a concentration of results at some point, and you use that as your baseline. For example, in this simulation, the baseline is the blue line, and this is the like the bottom percentage, in the top 90%. So most likely your stock price will be in this range for the next part. So yeah, as I told you, the new advanced financial data with the high frequency and minute by minute, second by second, that is the main issue we need to focus on. So this was a paper. I'll give a link to you all at the end. So what we did was we combined Monte Carlo simulations, and then we made an ensemble of machine learning models. So what an ensemble means is just why use one model when you can use like all of them? So that's pretty much the idea. So you can get valuable information from everything. So I think I have this will show you better how the flow of work works. So we start with the data, and then we put into an ensemble model. So RFR stands for random forest regressor. LSTM is long short-term memory. SVR is support vector regression, I think. Yeah, and SA is sentiment analysis. So this is a regression model. So this works. It is a bunch of decision trees overlapped on each other, similar to Monte Carlo. LSTM is another type of machine learning model. Sentiment. Now this is an interesting one. So finance is, I think, it is more of an art than a science because there is interesting ways because there's no correct answer to a trade. You can execute the similar trade, and different people will make different money or lose money. So one of the interesting thing is it is a behavioral problem as well. So, for example, sentiment analysis, what this does is you go to Twitter or some open source social media. Twitter is not open source anymore, but it used to be earlier. They might release their source code soon, so it might be against who knows. So suppose you want to know about Google. So you run the search term through Twitter or something, and then you get all the relevant tweets and churn it through a sentiment analysis model to see if people are talking positively about it or not. And then based on that, you assign them a score or something. So this is like the data goes into all these one by one, and then you make them do predictions. And they assign, for example, in sentiment, what we did was go from 0 to 1. 0 is absolutely negative news. Like if you take 100 samples, all of them are talking negatively about it. 1 is positive, and then there's a number between 0 and 1. And you put that all into a reinforcement learning loop. So if it makes a correct prediction, I must also emphasize this. For the training data, what we do is, for example, this is our data. We split it 80 to 20%. So 80% data is used in training the model, and the last 20 we do it on the testing. So on the 20%, if all these predictions do well, we give it a reward. For example, we reward it +5. If it does not predict well or goes in the opposite direction, like if it predicts very badly, it's like a punishment, I guess. You do it -4 or something like that. And then you try to maximize the reward function. And once that loop completes, you get pretty decent results. And then you go through this loop and then updated predictions. And then Monte Carlo is just for like your risk management stuff. See if it is making sense, if it is in between that range. And then you compare. So if everything goes perfectly, you make some profit. So this is just standard stuff, like high frequency data you get from Bloomberg Terminal or Yahoo Finance if you're using daily data. to do the data cleaning, standardized data. Stock splits another challenge. For example, sometimes you have a stock. For example, Nvidia did it recently. They reached around $1,000 per share. They did a 10:1 stock split. So now the price is around 100 something after the split. So this on the CSV file that has all the data. Sometimes it just shows up as a loss, like it will go from 1,000 to 100, and doesn't say the split was done here. So you have to adjust after that or before that. There is something to keep in mind. We talked about the random forest regressors, LSTM networks, sentiment analysis, and SVRs. So yeah, so we are mostly focusing on the S&P 500 SPDR. It's like 500 top stocks based on market cap, and then we can calculate all the ratios. That's what we did in this paper. So this is Dr. Ache from the math finance department. He has a ratio named after him. It's pretty good to get tail and risks. So that's when I got introduced to this department, because I didn't know how to effectively empirically calculate risk measures for the machine learning models. Machine learning models, they just give you a mean average error, like some error, but it is only machine learning. It doesn't have anything to do with finance. So how do you connect that? So Dr. Ache suggested using these ratios, and he suggested me a paper, and this work was able to move forward. So these are some of the results. These are the only results that you get from machine learning models. So this doesn't tell you anything about how risky is it if you invest in the price, or if you invest in that particular stock or not. So that's why we need the ratios. So based on these ratios, you can see, for example, Nvidia, they have the highest Sharpe ratio, the Sortino ratio. So it tells like it is one of the most volatile stocks. Like everyone knows that because it is the thing, but it gets reflected in the data as well. So it is a nice way to confirm if your model is actually useful or not. So yeah, some challenges and what I learned from it. So ensuring high quality data, balancing model complexity, high computational demands, and accounting for high volatility and stochastic nature of financial markets. That's all good. So this is where we are in the research process for the current paper. So we're doing model training and validation right now, and then comparative analysis, and then we integrate risk models, and then write up. So yeah, these are my references. Is the paper that I was talking about, and if you have any questions, I'll be glad to answer.
So, I've got model simulation, so I can understand. And you discuss about the stock market price between a time period. But suppose a country is facing a problem like war, for example, Russia, Ukraine, or other territory like in Palestine, or like in that case, financial condition might be lost
Mhm.
or decrease to different extent, and they need to financial support sometimes. In this case, this currently Monte Carlo model that we discussed, you can assess and the situation, the sustained situation of the financial condition of any country.
So yeah, that is a very interesting problem because like in case of a war or anything negative happens to the market, the like oftentimes we see like the major indexes they drop. So there might be ways to actually forecast like some events like that because, for example, like fear, this is called like the fear index. So there's a volatility index that's for every market. So yeah, so right now VIX is around like 17 something. I don't know why it was like going so well. It was like under 14 for a bit, but now it's 17. So so we have a suspicion that for high frequency data, there might be a way to see like how volume spikes creeps in, and like it might tell us like something big or something bad or very good is about to happen. So I'm not sure, but yeah, it might be possible, but it is hard to forecast these things. So
Thank you.